Hello. Sorry. Am I audible to all of you? Kudeza and Akib.
Yes, sir.
Okay. So Kudeja, this class is only for the NEET. Basically, whatever you will study in our regular classes of 11, we will do
Good
practice
evening.
of NEET questions. Good evening. Kudeja, am I audible to you?
Yes, sir.
So here we will be practicing only questions. If you have got any doubt in theoretical part of any topic, you can ask me. Okay, so in the last class, I gave a question, all of you. Did you solve it? Akib, Rishita, Kudeja, try this question. Kudeja, will you be able to solve this? Akib, you didn't solve this question. I gave you this as a homework. Akib and Rishita.
Sir, half is done. And calculation, I did mistakes. I'm doing again.
Okay. Rishita, what about you? Kudeja, am I audible to you? Will you be able to solve this? 10 M. I'll check it. I think it's wrong. Maybe. Akib got 1.25 M. Okay, I'm going to solve it. See, 10% weight by weight means what? This simply means 10 gram of solute present in 100, since it is percent, so 100, and this is your basically W, so gram of solution. What I want to tell you is that the numerator W is for solute and this denominator W weight is for solution. This is for solute and this is for solution. Now we need to calculate molality and aqueous solution. Always remember this aqueous, that means solvent is your water. Now you can see if you are going to calculate or apply the formula of molality. Molality equals to number of moles of solute, upon mass of solvent in kg, upon mass of solvent in kg. Now you can see in the question that we extracted the information. There is no number of moles of solute, but we can calculate number of moles of solute. That is equal to given mass upon molar mass. Given mass is 10 gram. Molar mass we can easily calculate of calcium carbonate, that is 100. How is this 100? So you know calcium has 40 mass, carbon has 12, oxygen has 16, but we have 3 oxygen. So after solving this, you will get 100 molar mass. Now you got the number of moles of solute as 1 by 10 moles. After this, mass of solvent in kg. How to calculate mass of solvent? You can see solute is your 10 gram and solution is your 100 gram. So mass of solvent will be equal to, you know that solute plus solvent. So I'm going to write mass of solute plus mass of solvent is equal to mass of solution. Mass of solution is 100 gram. Mass of solute is 10 gram. So you can easily calculate the mass of solvent, and that comes out to be mass of solvent that is equal to 90 gram. Now you can see molality that is equal to number of moles of solute that you calculated 1 by 2, and mass of solvent that is 90 gram, but we need to convert this into kg always. So what it will be, 1 by 10 into 1000 upon 90. So you can see the answer is 10 by 9 m, or moles per kg, because in numerator you put moles and in denominator you put kg, so it will be moles per kg. If you are going to divide it, 9 1 is 9, then 1 and 1 something molality. Is that clear, Kudeza, Akib, and Rishita?
Yes, sir.
Yes, sir.
Please do write it. Let me know when you're done with this.
Yes, sir, I'm done.
Finished, sir.
Rishita,
Yes, sir.
okay. Again, the next question I'm going to give you another question. Then we will move to the main question. And that is very simple. That is 49% weight by weight H2SO4 present in aqueous solution. Calculate molality. This is the last question on molality. So Deja, have you got it? Yes or no? Okay, the previous one. What about that? Were you able to understand that? Okay. I will check it. I think it's correct, Rishita. Martin, give any answer?
Solving, sir.
Okay. What is its in fraction? Okay, I'm going to solve this. See, 49% weight by weight. What does this mean? This means basically 49 gram of solute present in 100 gram of solvent. Now we need to calculate molality is equal to number of moles of solvent upon mass of solvent, number of moles of solute upon mass of solvent in kg. Now, number of moles of solvent solute is not given directly. We can use the formula given mass, that is 49 gram, upon molar mass 98. So the number of moles will be 1 by 2 mole. And mass of solvent, you can see mass of solvent will be equal to 100 gram minus 49, that is 51 gram. So you are going to put the value 1 by 2
Sir, is it
upon
like 9.8?
51 by 1000. What is 9.8? Answer?
Yeah, sir.
I will just check it. 1000 upon 51. So it will be 500 upon 51 moles per kg. Or you can write basically 500 divided by 51, that is 9.8. M you can write, or moles per kg. Very good. All of you. Is that clear, all of you, Khudeza?
Yes, sir.
Very good. Can I change the slide? Let
Yes,
me know if anyone is writing. So there's a Deja, can I change the slide? Okay. Moving to the next concept. And that is your the last concentration term, normality. Normality is denoted by N. So before moving to the normality, we will clear some concept or other terms which is related to normality, and it is very important. See, first of all, we will go for equivalent weight. This is very important. And what is equivalent weight? We can either write equivalent weight or either we can write equivalent mass. That is equal to molar mass upon X. That is equal to molar mass upon X. Now, you can easily calculate molar mass, right? Everyone can calculate molar mass. Just let me know. So if anyone
yes,
has
sir.
any, okay, if anyone has any doubt in calculation of molar mass, just let me know. I will explain. This X is what? So basically this X is either we call it valency factor or we call it N factor N factor. And this is denoted by here X, molar mass upon X. So first you are going to write this formula, then I will explain what it is valency factor and what is this N factor. Both are same term. Let me know when you are done with this so that I will start explaining X.
Finish, sir.
Very good. Now see what is
Sir, can you
this.
show that?
Yes. Please let me know when you are done with this. Are you done with this? Martin Suso.
Yeah, done, sir.
Very good. Now see what is X. See, X, we can divide this into three categories. For acids, how we calculate X. For base, how we calculate X. And for salt, how we calculate X. Okay. So basically, if we are going for acid is X is equal to number of H plus given. Number of H plus given. Like HCl. Can anyone tell me how many H plus will give this HCl? Since only one hydrogen is there, so HCl will give only one H plus. And hence, if you want to calculate the equivalent weight or equivalent mass of HCl, this will be equal to molar mass of HCl upon how many H plus it gives? 1. So molar mass, you can see 35.5 is the chlorine and hydrogen is 1. So it will be 36.5 upon 1. This is the equivalent weight of HCl. If you are going to calculate X for another acid, that is H2SO4, you know that this will give 2H plus SO4 minus 2. Now, if you are going to calculate the equivalent weight of H2SO4, this will be molar mass upon X. X is how much? You can see 2H plus given. So 2. Molar mass is 98 divided by 2. So it will be 49. Is that clear? So number of H plus given will be equal to the X for an acid. Is that clear, everyone?
Yes, sir.
Now, how we calculate X for base? So again, same number of OH minus given. Number of OH minus given, that is equal to basically X for base. Like if you have NaOH, sodium hydroxide, so you will see after dissociation that NaOH gives only one OH minus. That's why equivalent weight of this equivalent weight, molar mass upon X. X is what? Only one OH minus, so 1. Molar mass of NaOH is 40 divided by 1. If it is MgOH whole twice, you can see if you are going to dissociate it, Mg second group element plus 2 and 2 OH minus, it gives 2 OH minus. That means X for this will be equal to 2. So equivalent weight of MgOH whole twice, that will be equal to whatever is the molar mass of MgOH whole twice divided by 2. Is that clear?
Yes, sir.
And for salt like NaCl, X is equal to either total positive charge, total positive, or total negative charge. Basically, you know that total positive charge or total negative charge. Salt comes from neutralization reaction, right? So in neutralization reaction, the compound form is neutral. So if you are going to break that, dissociate that, it will give you equal positive and negative charge like NaCl. You can see if you are going, this is a salt, if you are going to dissociate it, it will give you Na plus Cl minus. Now, if you want to calculate equivalent weight, that will be equal to whatever is the molar mass of NaCl divided by the value of positive or negative charge without sign. You can see +1 is there or -1 is there. So anyone you can take. Okay.
But sir, how should we understand we should take positive or negative charge?
You can take any one of them because they both are equal to each other. Can you see any charge in this NaCl? It is neutral. So when you are going to break this, it will be whatever is the charge positive charge, whatever is the negative charge, they will be equal. See, -1 +1. You need to take without sign. If it is Na2CO3, see Na2CO3, which is a salt. So this will be Na plus CO3 -2. Now you can see 2 sodium is there. So you are going to make it 2. Now, if you are going to calculate equivalent weight of this, whatever is the molar mass divided by, either you can take positive charge. You can see one Na has one positive charge. So there is 2 Na. How many positive charge is there? +2.
Two,
And
sir.
negative charge, you can see -2. So the charge will be equal. So 2 it is. This is how we calculate equivalent weight. Please do write it.
Sir, I'm done.
Everyone is done with this.
Yes, sir.
Okay, very good. Calculate equivalent weight or mass of following. Very good, Khudeja.
Sir, can you solve any two SO4?
Can you solve any?
Any two SO4.
Yes. Na2SO4, if you are going to dissociate it, it will be Na plus, and this is your sulfate minus SO4 minus 2, and there is 2 Na, so it will be like this. So equivalent weight is equal to molar mass upon X. X is either you are going to take negative charge, either you are going to take positive charge. So one Na has one positive charge, 2 Na has plus 2 or minus 2. So you just need to do this. Na2SO4 has molarity 142 divided by this, so it will
Sir,
be
isn't it total negative and total positive? So it's 3.
no, 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 no. Either you are going to take total positive charge is plus 2, or total negative charge is minus 2, not 3 it is. Are you getting my point?
Yes. Sir.
And it is not 3. You are saying that this is your minus 2, that means 2, and this is only 1, not only 1. There is 2 Na plus 1 Na has plus 1, so 2 Na will have plus 2. Got it?
Sir, what will be unit?
Unit will be as it is. We say it equivalent weight, that is equal to 71.
Okay, sir.
It has no units. Yes, very good, Khudeja.
So can you do the first one?
First one,
Yeah.
say, what do you think? What it is, acid or base?
Base.
Base. How many OH minus is there?
Two.
You can see if you are going to dissociate it, it will be Ca plus 2 OH minus. Now, if you are going to calculate equivalent weight, it will be molar mass upon what? What will be the value of X? What will be the value of X?
37.
X, value of X. X is how many OH minus gives 2, so it will be 2. If you are going to calculate molar mass, it will be 74 divided by 2. That comes out to be 37. So please write all the question. In the next class, you are going to do this you have already did in your previous class, right? All of you, Kudeja, Akib, Rishita, and Martin. Please do respond, all of you.
Sorry, sir.
This topic you have already covered, right? In your regular class.
No, sir.
You haven't. Okay. So which chapter is going on in your class?
The four.
Okay.
So chapter 3.
Okay. Let me know when you are done with this. Everyone has written the question, understood the concept, yes or no?
Yes, sir.
Yes, sir.
Okay, so in the next class, what I wanted to tell you is that everyone has written the question, right?
Yes, sir.
Yes, sir.
So in the next class, this chapter will be completed theoretically, but we didn't do so many questions. So in the next class, your homework is to revise all the all the concept, revise all the concepts. Okay, the remaining concepts I will tell you, but like stoichiometry and your concentration term except normality. I'm gonna ask some questions.